Hi guys, thank you for watching this video, and in this video I would like to show you a new way of doing profiling, a really simple way. So my original motivation was that I tried to profile an Android application, and the built-in profiler was really horrible. I mean, the UI lagged, it was really unusable, and the sampling or profiling output was actually completely wrong because it sampled something completely different. To this day I don't understand what the hell actually it sampled, so it's absolutely useless. So then I tried to written my own profiler, because it's honestly it's not that hard actually, but let's go to the demo. So the profiler itself is actually just a single class or a single Kotlin file, so it's really small, really simple. So all what it does is actually you need to create the profiler and then call the profile method, which will basically profile any code you need. So it's a profiling on demand. You can start it and stop it precisely when you want, and then it will output a profile of the code that you want to profile. So let's profile a really simple code, like 3 lines of code, so basically sleep for half a second and download something from this URL, and then sleep another half a second. So here we can see the output of the profiler. So basically the main method spent 21% of its time in thread sleep. Then it did something with read bytes, and then again thread sleep. So this is just a standard console output, so there is no magic. You don't need any special plugin, nothing. You just need to include a jar file which hosts the profiler itself, and then invoke the profiler. That's it. So you can of course navigate using this standard ID highlight methods. So if we want to know where the profiler spent 21% of its time, then we just click here and we can see that it spent 25% of its time in a thread sleep. And so 55% it's tried to download something. So we can look into these read bytes, and then it calls OpenStream, and by default the profiler is configured to actually not go into Java or JavaX packages, because usually they perform quite well. But we can of course force it if we want to know what's going on behind the scenes. So we can just simply profile everything really, and then we should really see what's going on behind the scenes. So I expect that the profiler will spend the majority of the time somewhere in socket reader, or I don't know, maybe TCP/IP open or something. So let's try to find out. Yeah, it's a lot of code. It's HTTPS, so it's doing a lot of handshakes and stuff like that. So okay, so connect to 22% of total time. So okay, so a lot of code. But now you have a kind of a precise information what the execution did. So the profiler works in a really simple way. Basically, every 20 minutes, every 20 milliseconds, it looks at the thread stack trace, remembers it, and then when the profiling is over, then it simply gathers that information and draws this neat tree out of it. So some methods are called only once, and then they are marked by this special character like less than 0.9%. That means that it may be actually a mistake, because profiling by thread sampling is not that precise, especially for fast methods. It's quite accurate for longer or larger methods, but that's usually quite enough, because we are actually usually trying to look into the hotspots of our code, into the methods which execute for a long time. So usually we can just ignore those really fast, really small methods. So okay, so it spent a majority of the time in get equal stream, and then so 21% of the time spent in SSH handshake. Okay, but this is usually too much information, so I'm going to disable this, and we're back. Okay, so you can easily embed this profiler like anywhere. It's just a Java class or Java jar file, so you can call it actually not only from Kotlin but from Java as well, or basically any JVM running language. So let's maybe show some kind of more real-world case. So in here I have a Vaadin web application opened. It is a Caribou Hello World application, so it's actually a demonstration for oh crap. So it's a demonstration application for the Caribou DSL framework, but it will serve as well in this regard as well. So I just simply cloned this repository, and then I added this Suckless profiler as it's stated in a Suckless profiler web page. So I just added this repository and added the profiler itself as a dependency. So it's a really simple, it's just a simple jar. So you can see it in here. So it's just a jar which hosts a bunch of classes. That's it. So I've hit this thread sleep into the servlet code. So I expect this page to load quite slowly. So let's try to run it. So to introduce a profiler into the servlet, you just need to extend the servlet itself. So yeah, the page is loading quite slowly, and we need to detect why is that. So we just override the servlet and just wrap a service call in a profile method. So basically every service call will be profiled. So I expect there will be lots of really fast responses, you know, some kind of a Vaadin ping requests or something like that. But there should be one quite long invocation call, and yeah, we have found it. So it's 5 seconds. Now we need to check where the majority of CPU time is spent. So we now know that we can simply ignore those really short methods. So this is really just a noise. It's basically at that point the thread was sampled by accident at that point. So we are basically interested in the longer method. So yeah, we have one right here. So we can see that valid installed service took 99%. And yeah, going further, handler request call this handler request, and so on and so on. And this branch is totally useless because it's just 0.4%, so we dig in deeper. So my UI doing it, and it's in our code, my UI initialization. Okay, so a bunch of methods. Okay, we can once again skip this branch. It's, you know, Java class loading mechanism. We can ignore that. And yeah, 97%. So 95% and 95% thread sleep. Okay, we have found the culprit, and to actually see the culprit in a code, we can just simply click here. So yeah, and now you can just delete this line, and it should hopefully run much smoother now. So as you can see, you don't need no really expensive profilers, which you know, are not that easy to use, especially in production. So you can just use this really simple library. Of course, the disadvantage is that this library cannot attach remotely to any JVM or something like that. You basically, it needs to be included from the beginning on a class path, and it needs to be invoked. So, but still. So thank you all guys for watching, and see you again at some next